result you should see is a curve like this. Alright, this is what you learned in Cal 2. But we are talking about a differential equation. What's the difference? The difference is you have the y on the other side. If you have the y on the other side, you cannot do this way in differential equation. And you can take the integral to dy, but if you do this way, it's bad. Why bad? Because you don't know the y in the first place. This you don't know. You cannot do it by directly integrating, like what we did here, the cosine x, but we can do it numerically. The numerical idea, all you need is a backward link. That's like a feedback system. The information from the y flow back into the controller, as we showed you in here. Look, if you call this result as y, and this sensor send the information y into the controller, into the input, into the controller. That's why it's called the closed loop feedback system. So in that level, this y can come back. So the equation you can write as y right now equals y a moment ago plus the f t right now, and the y a moment ago, here's the key, just the t minus dt. That's a moment ago. And you can keep doing it. You know the y0 equal, for example, 1,000 or anything. And then you start from the first step, and then you get to the y1, 1 nanosecond, 1 millisecond, that's up to you, equal y0 plus whatever f you have, y1, y0. Now you know f, you know the y0, you have no problem in the numerical method. So that's the idea. We're not going into much detail. So in this case, you can always calculate the result step by step. And another little thing I want to point out is this. All right. In the run expectation, look, your dt by default is 0.25, but how small you can make it as 0.001 smaller, or even you make it infinitely smaller. Oh, that's the minimum. It's 1 out of 1,000. That's 0.0001. That's how small you can go. And you have different algorithm. The all built up here is called the Euler method. That's the straightforward method. Rank-Carter method, Rank-Carter 4. Usually you choose Rank-Carter 4. Will be more accurate. Anyway, this is the introduction to the stellar. I cannot go into detail, but I introduced this layers of structure. In the map layer, we call it a conceptual model. And in the model layer, you need to answer those questions. Like this is the example I did. Integrate the cosine x. The second one I did not run through. But we can, to find this relationship. And once you answer all those question marks, you get the mathematics model. And then once you finish it, and you copy down the equation layer, see what you have. The integral t equals the integral a moment ago, that's my y, equals y a moment ago, plus the integrand, in this case is the cosine x, the integrand is cosine x, and the times dt. Every calculation is real arithmetics. You only have multiplication and addition, nothing else here. And to solve the fluid mixing problem I did last time, you look, the amount of pure salt right now, T is right now, equal the amount of pure salt a moment ago, T minus dt is a moment ago, equals the enter rate minus the exit rate. And then you get the enter rate equal the concentration times the interspeed. Then exit rate is the concentration times the exit speed. And the concentration equal the total amount, that's the x, divided by the volume. Seems to come naturally. The good news is you don't need to write any of those. You don't. You let the stellar tool produce this automatically. But if you understand this, that'll help you to debug the mistakes you made. So when I run this stellar model, I get this curve, and then you're done. But not true according to the procedure I showed you last time. Well, in these slides, I talked about a double tanker fluid mixing problem. I would like to let you read this question yourself from the lecture notes. I don't have the time to go through this detail. But in these slides, I showed all the 6 steps you should have. When you read the question, and then next, you're going to identify all the facts. The best way is draw a conceptual model. A conceptual model is nothing more than the 2 tanks connected by the pipes. And then you know the relationship with the input water is going this way, exit this way, the speed are the same, you draw it. And when you read, you draw this one, goes 8 liters per minute. You're going to read this detail. And go back 2 liters per minute, and you just draw on the conceptual model. And once you draw this model, you refine it. You answer the question marks, and then you build this stellar model, which have all this volume, concentration, the speed, speed out. Those we call it convert. It's nothing more than the information, and those connections are the information flow, and then you answer the questions right here. Then you finished your math model. Once you finish your math model, then you run the model. I have a little more detail. You can choose Euler method, Runge-Kutta. I always recommend you to choose the Runge-Kutta 4. Well, then you answer your question by simulating the result. And after this, you observe your answer. And you remember this AJL means answer, justify, loop. The second step, verify your answer. Well, since it's solved numerically, it's very difficult to verify. But you do know the initial condition. You probably can know the average and the trend. But in the final, infinite, the situation, and this can help you to verify your answer. So in the last thing, I have a whole set of questions for you to answer to see if you really got a reasonable answer. I don't say correct, right answer, because a lot of application open-ended. And modeling is all about insight. It's not about those numbers, but those numbers will give you the insight once you do it right. So today, I try to give you a little overview about Stellar. My focus is on the philosophy, the idea, how you're going to build it up. Not about the detail. You get the detail from the tutorial I'm going to give you, not in the class, but in the office hours. There's one more thing. I said I have 5 icons. So far, you only see 4 of them. See? Stock, flow, convert, and the last thing, connection. So what does that mean? That's just a hierarchy. You can make this bigger to conturn, to put all those things. Let me see how I can make it big. That's a free version. That last moment is simply a module design. You can have 20 or 200 of those tanks. You cannot throw them all in this one page. Then what you're going to do is put them all together and then put your content here. So just modularize it, like you package your product, or you organize your software or your books, section by section. So this last one is really about how you're going to organize your things modularly. So the bottom line is 4 is enough. But how complicated this can go, we are going to see in the next 3 hours. And all the next 3 hours, we are going to revisit the population model and talk about the lesson matrix again. And we are going to talk about the spring mass system and the very good applications. And we use the Stellar to simulate it. Thank you for today. Thank you for your participation. I will see you next time.